Hi guys, in this part, now we are going to learn the next part of the interview question, which is part 7. In this, we are going to learn about performance, sorting, optimizations, and shortcut of creating tables and different recursion and everything, which generally asks after checking your basic knowledge on the indexes. So will be covering one by one. Stay tuned till the last time. They will ask these questions. How to create empty tables with same structure as another table. So they might say, how do you copy a table without copying its data if you want the same structure? So the shortcut is very simple. Create table name as select star from table where 1 equal to 0. To create an empty table, we can simply use this. What else we can do? The other way is select star into a new table name which is not exist from a table name which exists where 1 equal to 0. That also do the same thing. It create the structure and dump into the another new entity. Okay, it does not copy the data because none of the row is satisfying the where class. Okay? So there are two ways. Okay, so let's now see the another important question is the difference between the cluster and non-cluster indexes. So let's start with the basic structure first. Cluster index, how a structure looks like, internally how it works. So a cluster index determines the physical order of the data in a table. In other words, the row of table are physically sorted and stored on a disk based on the cluster index key. Each table can have only one cluster indexes. Non-cluster index. A non-cluster index creates a separate structure that contains a copy of index column and pointer to the actual row in the table. It means somewhere non-cluster is depend on the cluster index to look for the row. So you're seeing the relationship. It's dependent, but it's much more efficient. It's a separate structure, right? The rows of the tables are not sorted in the same order as the non-cluster keys. A table can have multiple non-cluster index. That's the advantage. Okay. Now in terms of sorting, right? In terms of sorting, how they perform cluster and non-cluster. So cluster index, the data in the table with the cluster index is physically sorted based on the cluster index key. Therefore, there is no need for an additional sorting operation when retrieving the data from our cluster index key, right? On the other side, in non-cluster indexes, the data in a table with a non-cluster index is not sorted based on the index key. To retrieve the data using a non-cluster index, the database engine performs a separate lookup operation after finding the relevant rows using the index. It means non-clusters pay the high cost for retrieval of the data even though it's an index, right? So these are the things you can include in your theoretical definition. Now in terms of performance, the data is physically sorted based on the cluster index key. We know it now, right? It provides a faster retrieval because it's already sorted, right? And it especially benefits for a range-based queries and when retrieving a large number of rows. Okay. On the other side, in non-cluster index, provides a fast access to the specific data based on the index key. That requires an additional lookup to retrieve the actual data, right? This extra may result in slightly slower performance compared to the cluster index. So you can say performance-wise, which is good, cluster index is always faster. But we can only create one, so that's the disadvantage. Now next is uniqueness. How unique they are in terms of uniqueness. So by default, a cluster index is created on a primary key generally, right? Which ensure the uniqueness. The moment you say primary key, it ensures the uniqueness, right? Now the non-cluster index can be created on both unique and non-unique columns of the. Next is uniqueness. How unique they are in terms of uniqueness. So by default, a cluster index is created on a primary key generally, right? Which ensure the uniqueness. The moment you say primary key, it ensures the uniqueness, right? Now the non-cluster index can be created on both unique and non-unique columns of the table. That is the place where interviewer will trying to check your knowledge. He will ask that question: can you create on a unique and non-unique columns a non-cluster index? Then your answer should be yes, we can. They allow duplicate index key values. Okay. Now uniqueness. Little more about the uniqueness, right? Cluster indexes. Since the cluster index determines the physical order of the data in a table, it is tightly integrated with table itself. Therefore, changes to the cluster index, such as inserting or updating rows, can be more expensive in terms of disk IO or storage requirement. On the other side, non-cluster indexes, we can say in terms of uniqueness, are stored separately from the table data using additional disk space. This separation allows for more flexibility in indexing and reduce the impact of index maintenance on the table itself. The next question is, they might ask, what do you understand by query optimization? Query optimization in SQL refers to the process of improving the performance and efficiency of SQL queries. It involves analyzing the query execution plan, considering various optimization techniques, and making adjustment to the query structure or database schema to enhance the query execution speed and resource utilization. So query optimization is the part of, once you understand the basic of execution plan, joins, sorting operations, merge join, hash join, table scan, index scan. When you understand these type of things by seeing the execution SQL plan, after that you think about how to optimize the query. What do you mean by trigger in SQL? Okay, a trigger is a database object that is associated with a table and automatically executes a set of actions or operates in response to a specific event or change made to the table. What does it mean? It means some set of code is keeping the security, keeping as a security guard, you can say, or keeping as a bodyguard of the table. You do anything, you try to insert, you try to delete, you try to update. You can have some set of code to be running in production or in just logging the information about that table. So it can also protect the table, like by not allowing you to insert the data. Okay, it can do that. Okay. So the trigger is very important concept. They definitely will ask in the interview questions, but heavily use of trigger will lead us in a problematic way that we will discuss in some other videos. I'll create a separate videos on the trigger. So stay tuned and subscribe if you wanted to wait for that video. Okay. So it can be triggered by various events such as I said, inserting, updating, and deleting, right? So in summary, you can give this information to the interviewer. Okay, so this is an example of a trigger. Simple create trigger on table name after insert, right? So how do we write it after insert? It means once insert is done, begin, simple, insert into audit. Now we wanted to just log that information into the audit table. When was it inserted and what was the time and what was the data is coming in. So we just want employees table. We want to have one more table called audit log, and we want to keep that information that what went insertion went to employee table, so we can capture the date and so many things. Okay, what do you mean by recursive store procedure? So here you must have heard about recursive CTE, right? So let's try to understand the same way. So we will be using a CTE inside the procedure and it will be calling itself. So you must have heard the best use of CTE, right? It's recursion. Okay, the recursive store procedure is a type of store procedure in SQL that call itself until a specific condition is met. In other words, it is a store procedure that contains recursive logic, allowing it to iterate or repeat a certain set of actions or operation multiple times. Let's see. So main focus over here is to learning the CTE inside the procedure. Okay, if you see, we are just taking one parameter called manager ID, and with that we are creating a CTE inside the procedure, and this CTE we are calling in the third join. So we have two set of queries. One is a basic manager ID, and then in the second side we are just calling that manager ID reference to the above CTE name. So this is a simplest example of recursion that they might ask you this question. So for that you have to practice by writing recursive queries with CTE. That will benefit you definitely. If they want you to write something, this will be the challenging task. So make sure you prepare for recursion. And if you give this example with store procedure, that give you more good impression. But the idea of recursion is nothing but repeat the data itself, finding the manager ID and then the employee who belongs to that manager, right? So it's a recursion pattern. I hope you understood. I hope you like these questions also. Thank you for listening. Thanks for watching, and if you wanted to know more interview questions, you can download our app, and in that you will get free SQL interview questions, Power BI interview questions, Snowflake, Databricks, and a lot of interview questions courses we are going to post free. No payment is required. Thanks for watching.